Hello everyone, we are from UniKL MFI, Bangi branch. We are from FKB11102 batch March 2025 students. Today we are going to present to you our calculus assignment project titled Application of Differential Calculus. Our lecturer for the subject is Dr. Ahmad Izul Fakhruddin Azimi. Here are our group members, Nafis bin Muhammad Fairuz, Mr. Imran bin Ismail, and Mr. Muhammad Hafizwan bin Rente. Now, let's go through our introduction.
Differential calculus is a crucial branch of mathematics that focuses on understanding how quantities change with respect to one another. It studies the concept of derivative, which represent the rate of change of a quantity. This powerful mathematical tool has numerous practical applications in fields such as engineering, physics, economics, and environmental science. One key application of differential calculus is in solving related rate problems. These problems involve multiple quantities that change over time, where the rate of change of one quantity depends on the rate of change of another. For example, when water is pumped into a container, the water volume, surface area, and height are all changing simultaneously. Differential calculus allows us to analyze this change and calculate unknown rates by differentiating the relationship between variables.
Differential calculus has been proven to help human beings advance by enabling precise analysis and prediction of changing systems. These advancements include the advancement in the field of medicine, energy, economy, and technology. Now, here is our problem. Imagine a conical tank with a height of 6 meters and a base radius of 3 meters. Water is being pumped into this tank at a constant rate of 2 cubic meters per minute. Now, we need to find how fast the water level is rising when the depth of water is at 4 meters. Now, how do we solve this problem? Step 1. We are going to identify the variables. We are going to identify the independent and dependent variables involved in the problem to set up the appropriate equations. For example, in this problem, we are going to let V equal to the volume of water in the tank in cubic meters unit, and then we are going to let H as the height of water at a given time in meters unit, and lastly, we are going to let R as the radius of water surface at the specified height H. Step 2. We are going to write the volume equation of a cone. We are going to express the volume of the cone using the formula below, which is V equal to 1 over 3 times pi r squared times H. Now, in this formula, they are relating the radius and the height to the volume. Since the tank is conical in shape, the radius and the height are proportional, meaning the ratio of radius and height stays constant throughout. And from the equation, from the calculation that we've done below, we got the value of R equal to H over 2. This is going to be used as an important later. Next, we are going to substitute the value of R from our calculation before, which is equal to H over 2, into the cone volume formula. We are doing this to express R in terms of H into the cone volume formula to write the volume as a function of height only. So from the formula of V equal to 1 over 3 times pi r cube pi r squared times H, we finally got the volume as V equal to pi times H cube over 12. Step 3. we are going to differentiate both sides of the equation with respect to time, which is t. Differentiation of both sides of the volume equation with respect to time t, we are going to use the implicit differentiation since the variables change over time. So after we differentiate the v pi h cubed over 12, we got dv over dt equal to pi times 3h squared over 12 dh dt. Then we can simplify it further into pi h squared over 4 dh dt. Step 4. We are going to substitute known values. Now, from our problem statement before, we have the rate of the water pump, which is dv over dt equals to 2 meter cube per minute. And then we know the height of the conical tank to be 4 meters. We are going to substitute the known values for the variables and their rates of change into the differentiated equation to solve for the unknown rates, which is we're going to find dh over dt. From our calculation in this panel, we can see after we substitute the value of dv over dt and the value of h, we finally get the calculation, the value of the rate of height over time, which is dh over dt. The value happens to be 0.159 with the unit of meter per minute. Finally, we are going to interpret the values. The result in the context of the problem to explain what the calculated rate means in real world terms. From the calculation that we've done previously, we can conclude that when the water is at 4 meters deep, the rate of water level the water level is rising at a rate of approximately 0.159 meter per minute.
Conclusion. This problem shows how differential calculus, particularly related rates, allow us to determine how fast one quantity, water height, changes with respect to another volume field in real-world scenarios. Such applications are useful in engineering, water management, and environmental studies. Such applications are useful in engineering where the flow of liquids into tanks or pipes needs to be monitored and controlled precisely for safety and efficiency. In water management, understanding the rates at which water level rise or fall helps design and manage reservoir, irrigation system, and flood prevention measures. Similarly, in environmental studies, differential calculus help predict changes in natural systems such as groundwater rechange rates, river flows, and the impact of human intervention on aquatic environments. This real-world application demonstrates the critical role of calculus in solving complex dynamic problems.
Presented in the panels is the references that we use in our assignment. We would like to thank our lecturer, Dr. Izul, for his knowledge and guidance throughout our assignment project. Thank you.